Now let me demonstrate how Python Interactive Console and Jupyter Notebook can be used. Let's begin with Python Interactive Console. So when we start here and we select Open with Python, nothing might happen visually. That's because Python console actually opens in a new tab of our terminal application. So we need to go here and select terminal. And as you can see, we now have two tabs, the one that we had opened with Anaconda Navigator and the new one where we have Lecture 1 environment open. And now we also need to type Python here. That will launch our standard Python interactive terminal. There are some basic commands that are suggested for you to be aware of, but other than that, we can start typing Python code. For example, we can do some simple computations like 5 plus 3 and type enter, and you can see we have 8 as a result. Then we can do some more complex equations. And we have computed that 10 plus 5 over 3 is 5. Not a big surprise. What else? In a similar way, we can now import libraries and functions. We will talk about import command later, but for example, we can start by typing import math to import module math that contains very useful helper functions. And you can always look into the contents of module or actually any object in Python user dir function. And this function takes the name of the object that you want to inspect as an argument. And we had a typo here. So as you can see, math contains a lot of different interesting functions, and they are well described in the documentation. As an example, it supports arctangents, hyperbolic arctangents, cosine, hyperbolic cosine, and other trigonometric function, as well as useful things such as square root or power. And all these commands actually modify internal state of this terminal. For example, after we have imported math, we now have the variable math that contains the representation of that module and references to all the functions. And we can address it. If we were to address this math variable before we have imported it, as you can see here, we have error that says name math is not defined. This error tells us that we need to do something to set value to this variable. For example, by importing some module. And this console is rather simple, but you can do some things with it already. You can also supply a Python script to it as an argument, and then it will execute that script right away as a program. And this is actually the default way of running Python applications from terminal. To exit, we will type exit and round brackets. Now from here we can also get directly into more advanced version that is called IPython. That stands for Interactive Python. The previous one was already interactive, but this one is even more interactive. This console has a little bit different representation. As you can see, it has some colors, but it does the same things. So you can still do the same mathematical equations directly. And as you can see, it shows in and in square brackets 1, followed by the command. And this means that this was our first operation, and it has been stored in the dictionary that is named in. I will explain what dictionary is later, but for now we can just treat it as some storage for our data. In this dictionary in, we have all the operations that we have executed ordered by time. If we execute the same command once again, we will see another entry in the list that contains the second command. Please note the capital letter of in. In a similar way, we can address the results of these commands. If we type out with capital O and press enter, we also get a dictionary. The figure brackets here indicates that object is a dictionary. And I must correct myself here, in is just a list. And list is different from dictionary by behavior, and you can see that it has square brackets around it. This is how you can distinguish them when they are written. The difference between list and the dictionary, in this case, the most important one, is that the list will contain elements ordered and they will have sequential numbering. So this is the element 0, element 1, element 2, element 3, and so on, while dictionary has elements that have arbitrary keys. and this is key and this is value, but we will get to that a little bit later. Please pay attention to the fact that output of third command here is not listed, because the third command resulted in an error, and we actually get none as a value of that result, and these type of values are not stored in dictionary. None is a special constant that says there is no value at all. You can operate on none in some ways, but in most ways you will receive errors. So none is usually returned as an error or as a result of some failing operation, or as a result of some functions that does not want to return any result. A useful command that is available in IPython is hist, H-I-S-T, and this command allows you to print out the contents of in array in a more human readable format, and you can also copy paste this output by right selecting with left mouse, dragging, and then selecting copy. And then you can paste this in some text editor, for example, and save this as a Python script. This helps you to preserve results of your development. You can also save your history directly in file by using save command. The save command takes file name as an argument, and then it takes any arbitrary amount of ranges. And you don't have to specify the resolution of the file name. It will be automatically assigned to .ipy for interactive Python. Okay, now let's look at a more advanced interactive tool. Let's look at a more advanced interactive tool. This is Jupyter Notebook. We already know how to install Jupyter Notebook and launch it. And we can also create new notebook using Python 3 as kernel. And we can give some name to this notebook. Now, this interface acts very similar to basic Python and IPython. So you execute code in so-called cells. And let's type 5 plus 3. And the only major difference here is that if you type enter, now it will just go to a new line. Instead of enter, to execute things, you need to type Control Enter. And it will produce very similar results. So we have in array with our command, and we now have output array with 8 as a result. I will sometimes call lists and dictionaries arrays because that is their function, but they still are lists and dictionaries by their nature. And Python does not actually have any class for array by default. The closest thing that we have in Python for arrays are NumPy arrays, but those are actually implemented in pure C, so it's not Python. And technically, lists and dictionaries are forms of array, just with different properties. If you run the same cell multiple times by pressing Ctrl Enter, you will overwrite the results of the previous execution here, but your global state will be the same. So doing this is effectively the same as adding new cells and running them sequentially. The only difference is that you will not actually see the previous cells and previous outputs. Let's try to get our results from out array as well. And as you can see, we have 6 values from out that are the same because we executed the same command 6 times. And let's add a new one that is different and see how that changes our results. And as expected, we now see new element with number 8 that has result of execution of command 8. But we don't see the execution of line 7 and command 7 because this line actually returns none. Otherwise, that will create a circular reference inside this out dictionary. Cells allow you to execute programs in parts, and this saves a lot of time. If you are reading large files, if you need to connect to some services, or if you need to establish some permanent connections. So this helps you while developing things because you don't have to recreate the same thing again and again. And you can treat notebooks as a smart calculator and interactive software. So everything that you write in here is essentially happening within your program, except that it never terminates until you restart the kernel. So your program is done only when you say it is. And you can rerun the same part of program again and again by modifying some input variables and see how certain parts of code behave. And you don't really need to rerun the rest of the program to see the results of your modifications. You can save notebooks in Jupyter Notebook and load them to continue your activities. The only large drawback is that saving only preserves input and output commands, but does not save the state of the kernel itself, so the data you have in memory will not be preserved. When you are developing something, Notebook is good to be a sketchbook, and when you are done with initial drafting, you can export your sketchbook into proper Python file and start editing more sophisticated software. For example, you can start separating your code into modules and functions. Doing that is available via Download As menu, and you can select python.py file. And you can see we have downloaded the .py file that we can open with our default text editor. And we will see both the comments in which cell this line of code has been added, what was the code, and basically all this stuff that is necessary to just rerun this code. But if you just rerun this in Python, you will not actually see exactly the same results. We will talk about this a little bit later.